All right. Just to be sure, Amaka, can you hear me? Oh, I don't think you can hear me. I don't think you can hear me. Let's go ahead. Okay. I think this is much better. Amaka, can you hear me? How clear is this? Because okay, I don't know if Amaka is on the stage. Guys, let me know in the chat if you can hear me. Unfortunately, it won't be as I won't be as audible as the previous sessions because um, I'm not currently in my workstation. So I think I can see a message already, so you guys can hear me. Good.
I can,
All right. Thank you. Thank you.
I can hear
Yeah.
you.
Yeah. Thank you. Thank you. Okay. So guys, I'm going to share my screen again. I realized that my mic was not I mean, I had to connect, from a different with a different device, for the microphone. So it wasn't properly connected earlier. I had to leave the call and join again. But I believe it's better this time around. So let's just dive into what we're going to be covering today. Um, First off, I think I would want to take some quick feedback here, right, from the previous classes. Let me know in the chat if you have any challenge, so far with JavaScript. If you probably have any challenge with the class and maybe the mode of passing the information to you. If you're having any challenge of sorts, just let me know. If you have any questions, right? If you have any questions, do well to also let me know in the chat. Okay. I'm going to quickly say a couple of things before we jump into covering what we have in Node 3, part 1, part 2, part 3, which is primarily focused on object-oriented programming and a couple of OOP principles that you should know. Okay, so we're going to look into some of those things. A lot of people just get carried away with object-oriented patterns, and they end up writing redundant objects that are probably not needed, methods that are probably not needed, all in the name of assumptions, right? People begin to make a lot of assumptions. So I'll give an example. You are asked to, you know, build maybe like a payment, yeah, maybe like a payment solution, and the first thing that comes to your mind is, okay, let's work on payment, class payment. Let me zoom in if you can. Maybe you can't see this properly. Let me zoom in. Okay, so you see people, okay, class payment, and they begin to write a bunch of, constructor objects, a bunch of method, transfer, right? The thing is, you should design your code before you even, write those code. I think I should take this off. You should design your code before you write those codes. So when I mean design your code, yes, we have things called, design patterns, but I'm not specifically referring to those design patterns right now. I'm referring to you as an engineer trying to understand, the shape of, your classes, what the methods should do, what it should return. These are things you should know. What are the parameters to pass in, right? Ask questions, ask the business questions or the customers questions. Try to understand what you pass in and what you return. Make sure you spend some time understanding what to do before jumping into doing it, right? Um, yeah, you might hear a lot of people saying just go in there and start coding. Okay, it doesn't really work well, right? So try to understand what you really want to build, what you really want to code, so that you don't end up introducing some bugs yourself, and you end up confusing yourself. I've seen a lot of people working with classes, and what they end up doing is they overload, the way they think about objects. They end up overloading themselves with a lot of moving parts that are probably not necessary. Things that you would have achieved with a simple function, you end up writing a whole class with over 50 lines of code, and separate a bunch of methods, right? And at the end of the day, you discover it is not, or it wasn't even necessary. Okay, so we're going to cover some things around we're going to cover some things around objects and their prototypes, right? Prototypes are basically, some of the older ways of working with, what we currently call methods, right? I mean, it's the ideal way it works, right? This is how it actually works behind the scene. Those methods, those things we call methods, they end up, they are basically prototypes of, your base function. But, JavaScript introduced the concept of class, basically popularly known as a syntactic sugar, because it gives you a very simple interface to, create these objects and add all the, behavior, which are the functions that you are adding to that object. But working with a class, it then makes it look like the way you work with classes and objects in most high-level languages, right? Where you create classes, you create the methods, you put in the parameters if possible, whether private or public. So we're going to revisit those things today, and I would get to explain some of these details here with you. Okay. If you are just cloning this repo for the first time, I realize that some of the things that work on my laptop because I'm using a Mac, and even on my Linux, it probably doesn't work on Windows, especially when it comes to the paths, right? And something like this, having a question mark, it doesn't give me an error here, but it would probably give you some error if you're using a Windows machine. So these are the things we're going to fix. I'm going to fix this. I'll make a different push this evening, right after the class, so you can go ahead and clone this again. Okay. If you still have any issue with cloning the repo, do well to let me know on the WhatsApp group or on Discord. All right, so let's get started. So nobody dropped a feedback or a message, so I'm assuming you guys are enjoying JavaScript programming so far, right? Okay, so the first thing we have here, objects and prototypes. And I was actually trying to explain that the ideal way that JavaScript understands some of the things we call method, they are basically, prototypes from what we call a constructor function. So when we did not have, this class, which was introduced in year 6, this is the way you would probably want to, create objects. The first option would be working with what we call object literals, right? So this is the first pattern, working with object literals, where you literally have your object and then you append some, some actions or some behavior to that object. So you see we have person, person.name, of course, is John, age is 30, and if you have person.greet, right? The expectation is this should go ahead and, give you this response, console.log, right? So if I do node main here, you see we have hello, my name is John. Okay, so this is one of the ways to basically create or map out actions. I mean, you would find a lot of people still doing this, especially when you're writing. Maybe you're working on a backend code with JavaScript. Although we haven't gotten to that, but just to show you an example, you know, most people would probably have something like this. They call it maybe like a person controller, right? And then you begin to see some of the controllers, structured this way. You see maybe greets, maybe you see eats, right? With some request and response patterns. We'll look at some of these things in the future, but I'm just trying to make you understand that yes, this pattern is still adopted, especially by the backend folks, right? So they begin to write some of their constructor code in here. Constructor code meaning, the functions that trigger some actions when you do API calls to the backend. Okay, so you are still going to see this kind of pattern very well, and it is still valid. Okay, so when you see someone writing code like this, although there are new ways to basically work with classes, but this is basically going to give you that pattern of having multiple functions within an object. Okay, so I hope that makes sense. Let's take this off. Let's look at the next pattern we have here. I mentioned, I call this constructor function, right? That is what it is. So this is a constructor function where you basically use a function. I mean, it's literally you using a function to create new objects, right? So if you scroll down on this material, you'll see an example of this being used. Let's grab this. Let's paste it in here. Okay, so when you use a constructor function, you see the way we add the methods, right? Or we add actions. Let me not call them methods because now we're not using a class per se. Okay, so you see the way we add those actions. We say person.prototype.greet, right? This would allow us add that functionality where you can then call person.greet. The moment you create a new instance of the person, just like this, const John equals new person, and this gives us we add those values which are our params here. The first one being a string called name, right, and the second item called the second item called age, which is a number. If you are writing code, and this is, yeah, I mean, if you are a newbie or you already have some experience here, I would advise you learn to work with this kind of documentation, right? It makes sense if you do things like this because when you start working with those objects, I mean, this can help you, especially when you're getting intelligence. This can help to say, okay, this guy is expected to be a string, right? This is expected to be a number, stuff like that. And yeah, so within your code, when you're using this, at least you have some idea what this would look like, right? You have some idea what this would look like. So now you see we have name, string, age, number, right? The reason you're saying this is because we have specified. Okay, so in case you're not aware that you can get this kind of pattern, yes, you can. Okay, and TypeScript might be out there, very good. It has its upsides, right? But if you're just writing plain JavaScript and you want to also get, to know the types that you're working with, this is a very good way to, have those types show up while you're working. Okay, so let's go ahead and put back the name. I'm just going to say John again, John, and the age 30. Okay, so when I run this, you see now we still have the same output. Hello, my name is John, right? And of course, you can go as far as saying I am 8 years old. That is wrong. Age, years old. Okay. So if I run this, I think I have an error. Where is that error coming from? So hello, my name is. Oh yeah, I think I forgot to put the this dots so that we can identify, that particular object. Let's clear and run this one more time. Yeah. So hello, my name is John. I am 30 years old. Okay. So this is how you work with prototypes. You can create more prototypes. So we can say we have a prototype of I don't know, maybe say hello, right? And yeah, so now if you have a prototype of say hello, we can go ahead and say, basically the same thing. We're using a string literal here, so we can say probably want to return, right? You can as well return this dot name, right? So I can say hello from, not in here, but outside. Hello from John. Okay, so this is going to tell us hello from John. So if I simply say hello right here, we're going to have, by the way, we have to console.log this, right? So that we can get the result, because now we're not using console.log within the function, we're using a return statement there. So we have hello from John. All right, so this is how you basically create, what we currently call methods when we use the class, right? And you are also going to find some people use this, but not as much as you would find people using the class pattern. Okay, so mostly some of the developers that probably worked with this pattern in the past, they might enjoy using it. I don't see any reason why you should use this. You can simply leverage on the new patterns. Except you find yourself working on an old code base, right? Then it makes sense to say, should I upgrade, right, or should I just fix? That's a decision for you to make. Okay. Let's proceed. You can read this through. So prototypes are mechanisms in JavaScript that allows objects to inherit properties and methods from other objects. Every object in JavaScript has an internal prototype, right, referred to as the proto. Okay, and okay, so this inherits properties and methods from. Okay, so basically you inherit properties and methods from this base internal prototype, right? which means you can also add, more prototypal, more prototype functions into other objects, under other constructor functions. Okay, you can add more, uh, you can add more functions into some of these, functions. I mean, it's weird, repeating the same thing, functions everywhere, but that's basically what it is. Okay, so this is a function, right? A constructor function, and then this is also you appending a function into that function, right? By accessing the prototype object. Okay, so right. So yes, we already covered some details about object-oriented programming, reusability, encapsulation, inheritance. I added a couple of other options that I would explain by the time we get to, I believe, part three, right? Aggregation and I mean, I just wanted to give you the basics of those, those patterns or those principles. Ideally, what we tend to focus on is just inheritance, encapsulation, and polymorphism. We've covered that already, and I believe you guys understand what those principles are and how to work with them. Let's look at the second material we have here. This class is pretty much going to be fast because we have covered some of the basics of these things already. So let's have our preview. Okay, part two. All right. So we already understand, how to work with constructors, right? And of course, we understand how to use the new keyword because we're trying to initialize a new instance, right? So if you take a look at this example right here, yes, you know what this should do. You have that constructor function, and when you say new, you are basically creating a new instance of that. You're creating a new instance of your object, right? Let's assume we call this human. We have name, age, we have maybe a number of legs. I think something more practical. Let's say we have employee, right? So we have the name, age, department, and maybe a salary. Okay, so the same way you work with the constructors, of course, that's what you're going to find yourself doing here. So this is a department equals department. Now, there's nothing wrong with changing the values. Most people prefer to change this to avoid confusions, but I think any pattern is fine. Okay, any option you choose to use is fine. So salary equals salary. Okay, so within this object now, we can simply create a new employee, pass in the necessary params. Now, remember I told you if you work with this pattern like this, you are able to help yourself. So we have string. This is a number. Okay, this is a string. This is salary. Okay, salary can be a number as well. So you can basically pass in. We have our name. Let's have the full name. Let's say John Doe. We have the age, department. So we can basically pass in that department. Now, if you're just creating this, if we say new employee, right? So you see, it gives us those properties. Okay. So the next thing we need to pass in there would be, let's put IT for our department. Then the salary, I'm simply going to put maybe 500,000. Okay. So right here we can just let's print console.log John. All right. Let's format this document. Save. Let's run this. So you see, it gives us John employee with those values that we passed in, and of course you can go ahead and start getting those values individually. So now we're printing just the age, department, okay, IT, and of course we can as well go ahead and print out the whole item. Probably if we have a method by simply saying employee, let's say function. Okay, so what I'm trying to do right now is, following what I've explained to you in part one, which is exactly working with the prototype, right? So we can as well do that. So what we can do in here is to simply say employee dot prototype dot get tax, for example, right? And we simply say, okay, now this is a function, right? And this function should simply, let's start by grabbing the tax by saying this dot, sorry, the salary, right? So if you get tax for now, it's simply going to print out, that salary, which is 500,000. Okay, and of course, um, let's do times. Let's just do 10% of that, right? So 10 divided by 100. So this time around, I'm simply going to say maybe tax equals. Remember, you want to say let's, okay, and then return tax. Now that's a very simple, formula that I put in there. So we can just run this. We're going to get that as the returned, value. Okay. So let's see what we get if we run. Yeah. So I said this is the salary. What did I put here? Oh wow. Okay. I just realized this was 500 million. Ah, you see what I'm thinking, right? Oh, I probably need that right now. Okay, so now we have 50,000 naira for the tax, right? So you see the way we were able to create, the prototype, and of course we can add more prototypes, right? Depending on what you're trying to, of course, achieve with your code. All right. So let's go back to part two. I think we probably, yeah, this is part two. Oh, I think it's still open. Okay. So yeah, by the way, if you have any questions, right, please drop your question in the chat. Let me take the next, let me use the next 1 minute to answer questions. If this is clear to you, I mean, I expect that this should be clear, from the examples we've given. But if you have any questions, drop it in the chat so we can, aha. So you said, let's assume we have like 50 employees. Are we going to be making instances for those 50 employees? Okay, good. That's a very nice question. Now, it depends on what you or how you are trying to use this. Remember, what we are going to do is we're trying to automate, like the process with our code, right? Which means you are probably just going to have one, okay? And you look through. Okay, let me put it this way. So let's assume you have those 50 records coming in as an object. Yeah, as an array of objects, if that makes sense. Yeah, an array of objects. Okay. So if you have those records coming in as an array of objects, what you do is using your for loop, right? Or for each loop. Okay. So you basically loop through, and while you are looping, you're creating those objects. You are probably saving the record to your DB, or you are doing something, saving it to a file, or it depends on what you're trying to perform, right? It depends on the kind of operation you're trying to carry out. Okay. I hope that makes sense. Okay. Do we have any other questions? Do we have any other questions? Binta, let me know if you understood what I just said, or if you want me to, probably, let's say, if you want me to probably give you like some examples. Okay. Okay, so I don't think you have any other question there. Um, but yeah, I mean, I was even thinking, okay, so just to respond to what you just asked, right? Again, remember that if you have those 20 records or 50 records, you are not going to statically put that in your code, right? You are expecting maybe someone is sending that in as as an array, right? And of course, it means you have like array of multiple instances, or you have array of multiple objects. All right. Now, when those objects come in, you definitely have to, create a new. Let me show you an example here. Okay, let me show you an example here. Let me see. I'm going to probably do that right here, the same file. So if you have like employees, so let's just call them employees. And these employees, so let's say we statically put this in here. We're going to have like, new employees, and I know this is what you're trying to ask. Are we going to do something like this, with different records, right? So 1, 2, 3, 4, 5, right? I mean, that's why I said it depends on what you're trying to do. In a more practical environment, this is not what you'll be doing, right? In a more practical environment, you would have a JSON. So kind of like this, you're going to have, let's do const employees again. So this would be more like an array of objects, right? Just as I mentioned. So those objects are like, we have name. Let's put this as John Doe, for example. We have the age, right? So we have the age, that would be 30. We have our department, that would be IT, right? Then we have our salary, yes. So our salary is 500,000, just like this. Now you're going to have multiple records. Now this is how it would basically come from your front end if you're working with the front end at the back end, for example, or even on your front end, you're going to have an object, right? So this can be a different name. So let's call this John Mary. Let's assume Mary has like 400 and Mary's age is 20. So this is an example. We just have two records, okay? So what would you do to basically iterate over this, right? You're going to create the record, okay? So now we can simply say maybe we can say employees dot for each, right? Of course, we've done for each already, and we're going to have this basically hold that single record, and of course track that to the index as well. Then yes, this is how you basically write for each loop. Okay, so this is the point where you can simply say, oh, I want to I want to check the salary for each, for each record, right? I want to check the salary for each record. So we can simply go ahead and say, I want to check the tax. I mean, so we can go ahead and just try to get the tax. So we can say employee.salary, right? So you see, we're basically collecting that value in here. You can also do it this way. Remember, so we're basically grabbing that key. Okay, so this is quite easier, and we can just say we multiply this by 10 divided by 100. So I mean, now that this is 400, this will be 40. And at the end of the day, we can return or log this. So it depends on what you're trying to achieve, but we'll get to work with objects this way, and of course loop through series of objects to perform different kind of different computations when we get there. Okay, but I hope that actually gives you some clarity, right, over this kind of operation. Okay, I hope that makes sense. Now let's quickly move on back to part 2 file. Okay, so all right, I think this is probably the major thing I wanted to show there. That difference. If you're working with a class, this time around, just to replicate the same thing we have here, but now you're working with a class. Of course, you're going to say class employee. You're going to have a constructor. Now this is easier to reason about. Okay, so name, age, department, okay, salary. Okay, and then you have this dot name. Let's use the same pattern. Equals name. Okay, this dot what's that? This dot age equals age. This dot department equals department, and this dot salary equals salary. Okay, salary. All right, so this is what we have right now. We need to put in the get tag, so you already know how to do this. Get tags, right? And then you can return. You can simply return this exact formula just like this. Let's go ahead and paste that in there. So now you see we no longer need all this. If you want to also include, the comment, just like I mentioned the other time, yes, you can include the comment. It makes sense to even include the comment. It would actually help you, right? And it's a good practice. Okay, it's a good practice. So try to remember, having a clean code this way makes sense. All right. You can also add some comments, to the not with this pattern, but with this. Okay. So this is blah blah blah. There's nothing wrong with doing that. But this is, I would say, the most important part here, because when you're creating a new instance, you want to be able to, identify the you want to be able to identify the type of data, right, to put in there, just like this. Okay, so exactly the same thing we've done before, but with a modern style of working with objects. All right, so we've covered things like inheritance. We've covered things like inheritance. We've covered polymorphism, right? We've covered encapsulation. Okay, so now that we've covered those options, you see I included a couple of options here. Aggregation. You can actually search the search the web. You would find some of these things. Aggregation. You would find something like composition, right? You would also find multiplicity. Now these are just they're just, I would say, for now, for you, right? They're just something that you can just have in mind, right? Over time, you're going to learn a couple of things that would make working with classes way easier, right? Probably you'll find yourself working with something like what we call method chaining. Okay. Um, yeah, so working with method chaining in JavaScript, working with method chaining with JavaScript classes. Okay. I will probably show an example. Okay, I'll show an example shortly. But let's talk about aggregation, which is the first thing here. So aggregation represents a relationship where one object contains references to other objects, right? But the contained object can still exist independently of the container, right? So it's more like it's representing that has a relationship, which means this has this, okay? But it can basically exist independently, okay? Um, yeah. So this is an example. You see, we have a class of book. We have the constructor for that, and then we have a class of library. And the constructor for the library basically holds numbers of books, right? It's an array. So you can simply say a library holds books, right? A library has a book. Okay. So and how do you basically include or how do you add those books into the library? You see, now we have a function or a method here called the add book. So when you say library.addBook, this is the part where you now have to, include the type, right, which happens to be a book, right? So you see right here, we have two books created. We created the library, right, the constructor, but of course this is empty, no param. And then we say library.addBook, all right? So we basically add that book in here, okay? Let's go ahead and, just replicate this. Let's copy, let's paste. So we have two books from this example, and this is where aggregation actually happens. So if we go ahead and run this file, of course, we did not, we did not return any detail here. We can just say console.log. Let's just see what we have in the library. Save that. So now when we run this, you see we have the library itself containing books, right? And then it contains book one and book two. Now these items can stay on their own, but now that we have it embedded in here, it makes sense to say the library contains books. And depending on what you're trying to achieve, your business logic, which is within your class, you can use this pattern to actually organize your code base in a better, in a more concise fashion, depending on what you're trying to build, right? It's all about your use case, okay? But the point is, yes, you can achieve something like this, and you can actually structure, records of objects, right, that were created from, a different class. Do you understand? So as you can see, this is a different class, this is a different class. Um, yeah, so this is a different class, this is a different class, and you are able to, create this kind of, aggregation. Okay, so I hope that makes sense. I hope that that is not, complex. I hope you understand the concept. Okay, so let me look at the charts if we have any questions. I think most of us are already familiar with this, but if you're not and you have any questions, please let me know. By the way, these examples, as you can see, were gotten from this material. So yes, you have access to these materials already. Um, oh, and I think, okay, if you don't have access to this material, I'll push it after the class. So you can simply pull, right, or clone. Speaking of composition, composition represents a relationship where one object contains another object as part of its state, right? So it emphasizes the part of relationship. Okay, so this is an example. We consider a car class composed of engine and wheel subjects. So we have the engine, and that that basically has this start method. We have the wheels that have the rotate method. So when we now use the car class, right, it has a constructor, that basically it expects to it's expected to create a new engine and a new wheel when a car is created. So when you initialize a new instance of the car, it automatically creates the engine and wheels for you, right? And then it gives you that method to drive. So when you now start that method, that action, which is to drive, you can simply call the engine.start, which is basically going to it's gotten from this set of classes or set of objects we've created. So what you are seeing here is we're basically building we're basically getting our main instance by building up several parts of our code, which is several classes. Okay, we have the class for the engine, we have the class for the wheel. We identify them as separate objects, and now we can bring those objects together to create a whole. Okay, so we have the engine, right, with the method. This is what an engine can do, right? We have the wheel with the method rotate. This is what the wheel can do, right? You can of course have different methods, okay? But if you look at this, one thing you would realize is that these items, they don't have constructors, okay? They just have different methods, and it makes sense. It makes sense because when working with code, you can have different parts that you want to model separately, but you know very well that this separate entities would eventually get to work together as a complete whole, okay, as a complete entity, right? So engine itself, we represent this as a different object, create all the methods and all the behavior, right? Wheels, we do the same, right? All the respective behaviors. And when we now build a car, we know that, okay, yes, we need an engine, we need the wheels, okay? So our constructor puts those items together, all right, just like this. And when we say card.drive, which is the behavior of the car itself, it is definitely going to then call or use some of the behaviors of the existing objects like the engine. So it will start the engine, and of course it starts rotating the wheels, right? So this gives you the ability to drive. Now this of course is an example, a very simple example, but you can begin to imagine the possibilities of working with this, especially in a real life scenario. Okay, so let's just assume that we're trying to compose an organization. All right, and now I haven't thought through this example, at least for the sake of this class, but let's try to create something that makes sense. So we have a class organization, right? And the class organization, okay, this is the main thing. Let's start off with maybe some departments. So we have class of, I would say maybe HR departments, right? So HR department has a particular action, maybe I would say to hire, okay? So hire. Um, Now, as I thought earlier, this might not make sense, but let's let's see where it takes us to. So we have console.log, hire staffs, all right. Then we have maybe the IT department. So IT department, build products. Okay, so that's a function as well as a method. All right, and we have console.log, build the products. Okay, so now we have the organization. It can be an IT organization or a tech company. I don't know, whatever it is you want to use here. Let's just work with a tech company. Now, the tech company, just like what we have here, it will have a constructor where it initializes, the other parts, the other units. So we have a constructor, right? So we have this. So yeah, we're simply following this pattern here. So we can call this, this dot maybe IT department equals IT departments. Okay, and this dot HR. Let's call that HR department equals HR department. Okay, so let's do some proper casing here. All right, and now we have okay. So looking at this, what is the major feature of this tech company here? We can call that um, let's see, release product. Release product. Okay, not bad. All right. So what is release product going to do? Before you release a product, you want to first hire some staffs, right? So we can simply hire some staffs. Just the same way we call this. So we're simply going to say this dot the IT department. We should start with HR. Sorry. So it doesn't matter where you actually put it in the constructor, but I just want to make this more organized. So the HR department, we can say what exactly is this guy able to do, right? So we can simply call, I think that should be that higher, okay? Yeah, I think I also forgot to do something here. What did I forget to do? Let's see. Oh yeah, this was not properly initialized here. So we can say HR department, that's higher. Does that make sense? Okay. So let's see if that actually makes sense. All right. I don't think that's bad. So let's go ahead and also say this dot IT department, right? And IT department, what exactly would IT department do here? Where is it? So build products. Okay. All right. So we're basically calling those methods. And if you look at what we've been able to do here, um, yeah, did I make any mistake? I think that's basically how it's. Yeah, that's probably correct. Very correct, I guess. So new. Oh, yeah, I think I also figured out where we made a little bit of mistake. These are classes, so yes, we need to actually create, new this, new that. Okay, so now we are able to access, these methods, right? Now the thing is, the way you would find some of the usage here, it will definitely differ from language to language. Of course, we are practicing with JavaScript. Try to focus more on the concept rather than the actual implementation. Most of these implementations you will definitely find them on the web, okay, on the internet. When you are working, Googling is something you're going to find yourself doing a lot. Myself, I spend my day to day, activities using different languages, for achieving different results. So when I find myself using JavaScript and there's something I can't remember, of course I look up, references, and there's nothing wrong with that. Okay, so learn to use references as well. So now you see we're able to compose a business. We have the tech company, when they are about to release a product. This is definitely an analogy that doesn't really make sense, but you have to, of course, hire, some people, right? And then you also have to, have that IT department, build the product before you go ahead and say, okay, now we are releasing the product, right? So I hope that makes sense, and I hope that simplifies how you work with the concept of composition, right? Now we have one more option that I added here, which is multiplicity. Most of these patterns, as I said earlier, these are basically advanced patterns, right? We have more, but this would help you by the time you understand where to apply them. It makes sense, right? By the time you understand where to apply them, or let's say when you get to the point of probably writing functional code, functional JavaScript, which is you not using the concept of OOP, you'll begin to see some patterns that are related. So the same way you can apply some of those things in the functional patterns, you can also get to replicate some of that behavior using classes and objects. Depending on your preference, you would make that decision when you get there. Multiplicity represents the cardinality of relationships between objects, indicating how many instances of one class are associated with the instances of another class. Now, this is a practical example. So let's consider a classroom class that has multiple student objects, right? So we have the students right here with the constructor. We have the classroom with the constructor as well, holding several students, right? And we're also able to add students. So now you can be telling yourself, oh, is this not familiar? Is this not similar to the other option? Well, it is, but if you look at this very well, you know that the concept we're trying to push here is to say students have to exist, within the classroom. So at the end of the day, you're going to be, I mean, it's quite similar to the first option where we have to um, do some aggregation, right? So I think we have a complaint in the chat. Amaka, if you're there, please, you can look into that. Okay, so right here you see multiplicity represents that relationship between the objects. So we're basically focusing on that relationship to say yes, the student actually belongs to the classroom, and if you end up having a different instance of the student, yes, you can tell that the students that belong to that particular, sorry, if you end up having a different instance of the classroom, right? Let's say you have classroom one with let's say 5 students, classroom two with five more students. Yes, you can of course see that reference and tell yourself that this student is expected to be in classroom one. This student cannot be in classroom two because that we actually did that that relationship. We did that mapping, and we know how this should be applied. Okay, so this is an example where you have a new student, you have two new students, and then we have a classroom, and we're able to assign those students to the classroom. Now we already understand the concept of inheritance. We understand the concept of encapsulation. We also understand, yeah, encapsulation, data hiding, where we actually work with, private, um, some private data, right? We're able to hide those information, and we perform that action by simply using a method that has access, right, to that particular item. So you can't just say bank account dot balance, but you have to call the method to then, perform that deposit or withdrawal. Okay, in this example. Okay, and even when you want to get the balance, you have to use a method to do that, and not you accessing the balance directly. Okay, so we've actually looked at this already. Polymorphism. Being able to extend different objects and append new kind of like override the function. You override the method, right? This is always coming out the wrong way. So it's a method because it's within a class. Okay, so you're able to override the method, and you can have multiple, you can have different class blueprints extending that base class. But of course, if a particular class does not have a method that overrides the base method, then that base method will be applied, right? Instead, that base method will be applied. So that is the concept of polymorphism. We've tried this already. We've learned how to do things like this already. One more thing I want to add here as I would say a bonus, right, before we end this class, is the concept I mentioned earlier, which is method chaining, right? Most people, love this pattern. I personally use this pattern a lot, when I worked as a Java slash Scala engineer, right? So method chaining was something I really enjoyed. Um, Let me give an example. We have a class, right? And we call this class a calculator. Okay, so now this is a calculator class. We have a constructor, and yeah, we want to accept a value, right? We want to accept a base value for this. So we say, okay, this dot value equals value, right? So we have created that base constructor. We want to add some methods, so just like add number. So we can say we're adding a new number, to the base value by saying this dot value, and then we say plus equals, the number, right? So this dot value equals, the number plus the value, right? I'm sure you know how this works, okay? All right, and we are simply going to return this. Now, this is what actually applies that method chaining pattern here. So because it basically returns itself, right? So by returning itself, you can append, more methods, and you can simply create your chain. So if we say subtract, for example, you are also going to subtract the number, obviously. So we can say this dot value, right, minus equals number. Okay, so I hope that makes sense. You can go ahead and add even more, like multiply, divide. Let's just include all that. So let's have multiply. So multiply number. All right, so this is the value. I think I can just copy this guy. Let's paste, multiply just like this. Okay, divide, divide. Okay, so this should be divide. Okay, so now this is good. Let's have a way to get the final result. I can call that get result of, okay, just get result is fine. This is not accepting any parameter. We just want to use this to get the result. So we can say this the value. Let's try to now, apply. Oh, by the way, I think I forgot. Our method chaining is, gotten by returning, the entire instance itself, right? So this is the point where we can now do something like we can say results. Sorry, this is results equals. Let's create a new calculator here. So I'm going to say new calculator, and we put in the base value. Let's work with 10, right? We can start adding some, chains like add. We add 5 to 10. We can subtract 2, for example. Okay, we can multiply. All right, let's multiply by, I don't know, 2. And we can end up getting the result. We can decide not to even do all this. Let's just say get result, for example. And this would basically end that chain. So I'm sure you might have seen patterns that look like this. Yeah, if I should run this, we're going to get that value. Let's go ahead and log results. So we'll say console.log results. So if I run this now, you see I have 15, right? 10, yeah, 10 plus 5, 15. Let's subtract 8. Okay, let's run this. So now you see I have 7. Let's multiply by 2. Okay, so now you see I have 14. Let's divide by 2. Again, that should give us 7. Okay, divide by 2. 7. All right, so this is method chaining. I'm sure most of you will like it. We have a couple of patterns that we'll learn over time. I would introduce some of these things gradually during our classes. I did not plan to show something like this. So what I will do is I'll put this in a different. I'll just call it a bonus directory, right? So bonus, because we had a little bit of time. Let's include this as main.js within the bonus directory, or let's call this method chaining, right? Okay, and let's also take off the question mark from this file so that most of you will be able to pull. Okay, let's go ahead. By the way, if you have any questions, please drop your questions in the chat. Let me take a look at the chat one more time. Please. So, Marv, I wish I can just. All right, thank you. Please, do we have any other questions? Amaka, if you're there, please help us, sort out the attendance, right? If you can hear me, please take a look at the chat and sort out the attendance. Okay, if I have any moderator in the chat, please reach out to Amaka. Okay, I think she dropped an updated one already. So apologies, guys. Go ahead and use the updated version. I would give you guys 2 to 3 minutes on this call extra, so you can click on that link, fill the attendance before I end the stream. Right? Uh, Enjoy yourself, and yes, would continue in the next class. Okay. All right.